This is the page 158 assignment number 26. And first of all, just a couple of changes from your book. One thing, the number 26 in the book asks you to write a paragraph proof. And we'll be talking about paragraph proofs in the future. It's basically the same thing as a two-column proof. It's just the format looks a little different. You write it out so that it looks like a paragraph instead of the two columns with statements and reasons. Another change I'm making from your book is the book asks us to asks us to prove the same side interior angles theorem. And if you look at your notes, the conclusion of the same side interior angles theorem is that when parallel lines are cut by transversal, we have supplementary angles. The problem in your book asks you to prove that the measure of angle 1 plus the measure of angle 2 equals 180, but I'm just going to take it one more step. Let's go ahead and prove that they're supplementary. That will only take one extra step. So I'll just tell you up front, this proof is going to take 8 steps. I'm going to get you started on some of them and give you a few hints so that you can finish it on your own. Okay, so let's see what we're going to do here. The same side interior angle theorem says when two parallel lines are cut by a transversal, same side interior angles are supplementary. All right, so our given statement in terms of this diagram, oops, I forgot to label the lines. This is angle R, this is angle S, so we're going to assume that line R, and line S are parallel to each other. Since we're assuming that, let's go ahead and mark the lines parallel, okay? And then our proof statement will be the conclusion of the same side interior angles theorem, and that is that we have a pair of same side interior angles supplementary. Okay, so what we're going to do is prove that these two angles are supplementary by showing that the measures of their angles add up to 180. Okay, so it looks like we better start with our given statement, which is that we have a pair of parallel lines. So let's say in step 1, that line R is parallel to line S, and the reason, of course, is given. We're assuming that R and S are parallel to each other. Okay, and then notice on our diagram, we also have this angle 3 labeled. And if you look at angles 1 and angles 3, what kind of a pair of angles are they? Well, they're on the same side of the transversal. They're both below the two lines being cut by the transversal. So those are corresponding angles. All right. And if you remember our corresponding angles postulate, it says when parallel lines are cut by a transversal, corresponding angles are congruent. So we can go ahead in step 2 and say that angle 1 is congruent to angle 3. And the reason why, now don't put the name of the postulate here, I want you to actually write it out in shorthand. And it says, whenever we have parallel lines cut by a transversal, we can conclude that corresponding angles are congruent. Okay, we assumed we had parallel lines, so we can conclude that 1 and 3 are congruent. Okay, now, if 1 and 3 are congruent, okay, if you look at your definition of congruent angles, you'll see that we can conclude that if angles are congruent, their measures are equal. So in step 3, we're going to say that the measure of angle 1 is equal to the measure of angle 3. Okay, why is that true? We know the two angles are congruent, so we can conclude their measures are equal because of the definition of congruent angles. All right. Now, looking back at your diagram, look at the angle pair 2 and 3. Okay, what kind of a pair of angles are they? Well, they're adjacent, and their non-common sides form a straight angle or a straight line. So angle 2 and angle 3 satisfy the definition of a linear pair. So in step 4, we're going to say that angle 2 and angle 3 form a linear pair. Okay. Why can we say that? Why can we justify that? Because, take a look again, they're adjacent, their non-common sides form a straight line, so therefore they satisfy the definition of linear pair. Okay, at this point, I'm just going to give you some hints because I think you can finish this on your own, okay? Remember the linear pair theorem that we proved, okay? The linear pair theorem says If two angles form a linear pair, then they are supplementary, right? So the next step you're going to say in step 5, you're going to say that angles 2 and 3 are supplementary. Back that up with the linear pair theorem. If they are supplementary, then we can say their measures add up to 180 because of the definition of supplementary angles, okay? Now, remember what we were trying to prove. We were trying to prove that 1 and 2 were supplementary, okay? Right now we know that the measure of angle 2 plus the measure of angle 3 adds up to 180. Well, remember back in step 3, you said that the measure of angle 1 was equal to the measure of angle 3. So, saying that the measure of 2 plus the measure of 3 equals 180 is the same as saying the measure of 2 plus the measure of 1 equals 180. Okay, so take a step to say that these two measures add up to 180, and then use substitution to rewrite that step, replacing the measure of angle 3 with what it's equal to. Then, once we have the measures of angle 1, the measure of angle 1 plus the measure of angle 2 adding up to 180, your last step will be to say that angles 1 and 2 are supplementary because you have shown they satisfy the definition of supplementary angles.